I'm Mrs. Pizzo, Director of Education here at WKAR, and I am so glad you can join us. We are going to have a lot of fun investigating STEM. We have the Curious Crew here today and lots to be curious about ahead. Let's meet our Curious Crew members. Tell us your name, grade, and what you love about science.
Hi, I'm Rashab. I'm in seventh grade, and what I love about science is finding solutions to problems with other people and discovering new things.
Hi, my name's Callan. I'm in seventh grade, and what I like about science is all of the new things that there are to learn.
Hi, my name is Ian. I'm in ninth grade, and what I love about science is being able to innovate and let my creativity flow.
That's wonderful. Next, we'll follow along as the Curious Crew investigates acids, basketball science, and polymers. And then the Curious Crew will help me explore chemical reactions as we create elephant toothpaste. Have you ever seen an elephant brush their teeth?
I don't think so.
No.
Either.
Me either. So this is going to be a lot of fun. We'll get things started with special messages from our WKAR partners in science. Enjoy.
Learning in Michigan has changed. The Michigan Learning Channel now allows learning from anywhere. On air, online, on demand, and it's all available statewide for free to students, parents, and teachers from Michigan's public television stations. For more information, visit michiganlearning.org.
Hi, I'm Rob Stevenson, and this is
Curious Crew!
That's right. Welcome to the show, everybody. We always like to start with a couple of discrepant events because discrepant events stimulate
curiosity!
Exactly, and I've got some fun ones for you today. So you're gonna notice I've got these beautiful yellow pieces of paper, but I also have my special Curious Water. Safety first, though, my friends. We're gonna do something interesting. I'm gonna take this Curious Water and spray it on this piece of paper. Now watch closely. Oh yeah, isn't that cool? Okay, that's interesting. I also have a little larger container of the Curious Water, and I'm gonna dip my hand in there for a second. Ooh, a little shaky, shaky. And I'm gonna put it right there. Watch what happens when I remove my hand. Oh my! And I have one more thing I would like to share with you. Notice this. Nash, what do you think's gonna happen when I add this into this?
I think it's either gonna turn red like that or it's gonna fizz a little bit.
Okay, turning red or fizzing. Ooh, so I'm gonna stir this up for a second. And Jake, I got a wondering for you. Do you have any observation about those two things?
Well, I think we all know that this is not real water.
Something strange about that water. It makes you kind of curious, doesn't it? Okay, I'm actually going to get another liquid, and I'm going to put some of this in here, and I'm gonna stir it up as well. Ooh, I'm already seeing something happening now.
Yeah. Disappearing.
It was pretty.
Whoa.
Whoa, okay, that's kinda cool. Let's pull those off for just one second. Now I've got a question. Does anybody have a guess what we might be talking about today? What do you guys think? Gentlemen, what do you think?
Does it have anything to do with chemical reactions or acids and bases?
It actually does have to do with both of those things. We were talking about acids and bases today, and we really did see some interesting chemical reactions. Now, to try to figure these things out is gonna take a little bit of work. So I'm gonna challenge a few of you to do a little scientific modeling. Who would like to try it? Okay, Olivia, Genesis, and Ian. All right, the three of you are gonna use the clues throughout the show to see if you can figure these out. It's fun.
When we put the handprint on the paper, it kind of seemed to turn red. And we know color change is an example of a chemical reaction.
I noticed that in the second discrepant event, it turned reddish.
Wait, did you guys notice the smell?
Yes.
One of them smelled like vinegar, and the other one smelled horrible. I'll draw the beakers.
Acids and bases are chemicals that we classify on a spectrum called a pH scale, where one end is more acidic and the other end is more basic. We can find some degree of acids and bases in most liquids. Lemon juice, for example, is acidic, shown with a pH of 2, while distilled water has a pH of 7, and soapy water is more basic with a pH of 12. Liquids with more hydronium and hydrogen ions are more acidic, while liquids with more hydroxide ions are more basic. Nice. Hit that rebound.
The basketball episode was definitely one of my favorite ones.
Check it out!
We shot some free throws.
Nice.
And then what he talked about is the parabola of your shot.
We're actually gonna follow the ball in this sort of an arc, right? You ever notice that? It's called a parabola.
The higher your arc is, the more circumference it gives to go into the basket.
Ooh, that was a beauty!
As much as I didn't think basketball had anything to do with science, it did.
There you go, look at that!
It helped me visualize that science, it can be done anywhere. It can be done at home, it can be done in a laboratory, it can be done at school.
You guys had fun with basketball science? Yeah! Awesome! Did you know that polymers are all around us? It's true. In fact, anything made of plastic is a kind of polymer. But so are the proteins in hair, fingernails, or a shell of a tortoise. A few other examples of polymers include cellulose and paper, rubber, and a really fun example, silly putty. But what do they all have in common? If we could look at them through powerful microscopes, we would see that the molecules are like long repeating chains bonded together. This structure makes it possible for polymers to behave in very interesting ways. Wasn't that cool with that disappearing water, you guys? Okay, we need to explain this a little bit. Polymers are really long molecules. Link my arm for just 1 second there. Link on, link on. If we were to link on together like this, they're like long molecular chains. But something strange about these polymers is they'll behave in unusual ways. Now, I've got a couple of gummy bears here. You guys ever eat gummy bears?
Yeah.
Oh yeah, they're so yummy. Okay, but I did something to these gummy bears yesterday, and I put some of them in different kinds of water. I put some in distilled water, I put some in tap water, and I put some in salt water. I'm gonna pull out one from the salt water container real quick, and I'm just gonna put it next to one of these so you can compare. So, what do you notice first?
It shrunk.
It shrunk! Oh, that poor little gummy. It shrunk a little.
It looks like blue.
Oh, it kind of changed color a little bit too. All right, I'm gonna pull one out of the tap water, see if I can get it without hurting the gummy. What?
It's
What?
huge.
What's going on with that gummy? I'll even turn him around so he's with his friend. Oh my gosh. Okay, and if I'm careful, I can get one out of here with the distilled water. I broke his little head. I broke his little head. Look at how huge that is. That's without his head.
Distilled water is bigger.
Okay, that's a really good observation. Now, if I carefully put this on my scale. Now, when I measured these at the beginning, they weigh about 2.3 grams. This one weighs 13.678. It's moving around a lot because it's jiggling. It has gained a lot of weight, hasn't it? Now, the strange thing about gummy bears is they're made of gelatin. And when you submerge gelatin in water, we can actually get them to swell up. In fact, if you look at these beads, these started off as these teeny, tiny little beads right there, and I put them into distilled water, and they swelled up. Now, I've got some other things that I just think are amazing. These toys are called grow toys. This worm, it started off as 12 centimeters long, and look at this, it's all the way over here almost to 41 centimeters. Now, the crazy thing is, there are polymers on the inside, there are polymers on the outside. The polymers that are on the inside like water. So it absorbs all that water, and that molecular chain holds more and more water. The polymers that are on the outside don't like water, so it keeps the shape, and it just keeps growing like this massive shark that's really grown a lot. How big was this before there? The shark was 17 centimeters. This is already at 34. That has grown a lot, and you can imagine, is it holding a lot of water? Yes. You want to have some fun with gummy bears? Put them in distilled water, because as you can see, they swell up a lot. Polymers are amazing. Polymers are made of long chains of repeating molecules that get bonded together when the molecules share electrons. When we feel the wet, growing toys or gummies, they feel squishy, kind of like rubber. In fact, rubber is another example of a polymer that occurs in nature. Rubber is really useful because it has that elastic, stretchy quality. Engineers have also figured out how to make different polymers that have different properties. Not only elastic qualities, but inelastic, reflective, translucent, moldable, strong, weak, or soft. Changing the structure of the polymers will change its properties. You guys ready?
Yeah.
Awesome. Go ahead, have some fun.
I was in episode 501, which was polymers.
They're like long molecular chains.
We did experiments with atoms and learning about the different chemicals and bonding and all that fun stuff.
We're gonna actually make 3 different kinds of slimes.
We mostly did slime, which was fun. We were using separate chemicals and different concentrations, trying to create different textures of slime. That got really thick really fast. The slime was very sticky. It was all over my hands, all over everybody's hands.
Mine is so slimy.
It was very weird to see how it all worked. It was strange.
It's way too much fun, don't you guys think?
Yeah.
Are you curious about careers in science?
Hi, I'm Jenilyn, and today I'm with Kelly Stano in Detroit, Michigan. Kelly, tell me, where are we and what do you do here?
We are at Little Caesars World Headquarters, the Global Resource Center, and I am a licensed cheesemaker and a quality assurance manager here. My job is to make sure that the food is wholesome, safe, and tastes great for our customers. We make sure that people receive the best quality pizza by monitoring our suppliers, and then we look at the ingredients here in our quality assurance lab to make sure that they meet Little Caesars quality standards. So this is our salt analyzer, and this measures how much sodium is in our products.
What kinds of ingredients do you test?
We test the sauce, the cheese, the flour, all of the toppings, everything that goes into making our pizza, we test, up to and including packaging. Jenilyn, are you ready to make some pizza? We have something special for you.
You do?
We're making you an official member of the Little Caesars QA department.
Oh my goodness. Thank you. Tell me, what's the process of making pizza?
First, we put the dough into the pans and we allow it to proof for a little bit. And what that means is it warms up and the yeast create more flavor. And then we're gonna take the dough and we're gonna press it out into the pan. Then you put a ring on the pizza and that keeps the sauce and the cheese contained. We're gonna add the sauce and we're gonna put it on.
Should the sauce be all the way to the edge?
Almost all the way to the edge. You add the cheese, and then you add all the toppings that you want, and we bake it. They're gonna bake for about 6 minutes. Look how fantastic they look. And we eat it.
Kelly Stano from Little Caesars taught me that any way you slice it, you can make supreme pizza with STEM. Explore your possibilities.
So let's get started with our cool investigation exploring chemical reactions. Remember, we're going to create elephant toothpaste. Even if you don't have an elephant, you can have its toothpaste. Let's review our materials. We need an empty plastic bottle, hydrogen peroxide, water, dish soap, food coloring, yeast, measuring cup, a funnel, pan with deep sides, a small cup, a teaspoon, a tablespoon, and of course, safety glasses. We're gonna now start by putting on our safety goggles and our gloves, because remember, Curious Crew, what do we say?
Safety first.
Safety first.
That's right, safety first. Now to review our procedures. First, number 1, dissolve 1 teaspoon yeast into 2 tablespoons of hot water. Number 2, place empty bottle in the center of the pan to catch the mess. Number 3, measure 1/2 cup of hydrogen peroxide. Number 4, add several drops of food coloring to the peroxide in the measuring cup. Number 5, place the funnel into the bottle and pour the peroxide mixture in. Number 6, add a good squirt of dish soap into the peroxide. Number 7, remember, you should have on your safety glasses. Number 8, pour in the yeast mixture. Number 9, you're gonna fill the bottle for any temperature change, but then step back to observe what happens next. Now, our Curious Crew members are going to do the investigation right at home. You can get started, guys.
Okay, so first I have to make my yeast mixture. So I'm going to be adding my yeast and water.
Yeah, and do you know that this warm water is actually a catalyst for the reaction that's going to make the elephant toothpaste? A catalyst is something that speeds up a reaction.
What else do they use yeast for?
Baking
Don't
bread.
they use it for baking bread?
They do. Do you guys like warm baked bread out the oven?
Yeah.
I do.
Okay, now on to step 2.
Now I'm adding my yeast to my hot water.
I'm also doing that right now.
Time for the hydrogen peroxide.
Oh, so I see Rashab is starting with his hydrogen peroxide. What else do we use hydrogen peroxide for?
Cleaning, right?
Yes, cleaning out cuts and scrapes and any kind of wounds that we might have from having an accident.
Okay, make sure we stir it around.
Everyone's measuring. Why do we measure in science?
Well, if we don't measure, then we have no clue what's going to happen. So something could explode in your face or do nothing.
Whoa. Add the blue food coloring.
Oh, so you chose blue, Rashad. Very cool.
Yeah.
Like our Curious Crew shirts.
Uh-huh.
So my yeast is really, really pasty, and I don't know if I'll be able to pour it in, so I might just add a tiny bit more water.
I think that's good problem solving.
No, I'm also going to be working on my hydrogen peroxide and food coloring mixture.
This is so exciting to see what the chemical reaction will be when everything is mixed all together. What step are you on, Rashab?
I just poured in the dish soap.
And Rashab, can you lower your camera just a little so we can see your, oh, wow, look at that deep, dark blue color.
Yeah. I'm wondering to see what the result will be.
Sometimes when you use peroxide to clean out a wound or a scrape, it has a certain type of reaction. Does anyone know? And does it ever bubble up a little bit?
Yeah, it releases energy. It's called exothermic, right?
Yes, very good. So as you're making your elephant toothpaste, what characteristics are these items, materials similar to toothpaste?
Well, I know toothpaste is supposed to clean your teeth, and hydrogen peroxide cleans wounds and things like that.
That's right. And what about dish detergent? Don't they clean dishes?
So right now I'm adding my food coloring. Whee!
And what color did you choose?
I chose red, just like the tablecloth here.
Oh, very cool. Is that another characteristic similar to toothpaste, that it might come in different colors?
Yeah.
Yeah.
All right, Callan, I see that you have chosen yellow for your toothpaste color.
I have. I like yellow. It's a pretty color.
Yes. Very cool. Well, it seems that you guys are all at the most important part, which is to mix all of the chemicals together and to pour the yeast mixture into the beakers with the dish detergent mixture. So if you want to go ahead and get started, let's go with Callan first. Let's see what happens.
Okay. Oh, wow.
Wow.
That looks so cool.
That is so cool. How about you, Ian?
Okay. Whoa.
Whoa.
Awesome.
It just keeps going. It just gets bigger and bigger.
And what texture is it?
It's like really fluffy, and it's actually really warm as well.
Oh, wow. Let's go, Rashad. Let's see yours.
Okay, here goes nothing.
Whoa. That is called an exothermic reaction. When things put together chemically warm up, it creates an exothermic reaction. Wow, look how much you're getting out of that. I would think we need a lot in order to brush an elephant's teeth, don't you think?
Yeah.
Yes, and maybe that's why they call this elephant toothpaste. All right, now that we've completed our investigation, how do you guys feel? Would you ever choose to brush an elephant's teeth?
I don't know.
I don't think so.
Maybe, but I don't know if this would do the job.
I don't know if that toothbrush would do the job either. Well, you guys did a great job with this investigation. And if you, friends, would like to also do this investigation, make sure you have an adult present with you and check out our curiosity guides at WKAR.org Curious Crew Curiosity Guides. We hope you learned something new and enjoyed the investigation. Thank you for joining us.
Bye.
See ya.
See you later.
Are you feeling curious?
Yeah!
Are you guys having fun this morning?
Curious Crew started when Susie Elkins saw me present doing a keynote, and she had a brainstorm.
I saw him get an award, and the parents treated him like a rock star. They just loved that he was able to inspire a love for science in their children, and it was that inspired me to want to make a show with him.
What do you notice?
Gosh, this is crazy.
What do you notice?
Being on the show with Dr. Rob is really cool.
Oh, that was awesome! I have a reputation of doing a lot of hands-on investigations.
Oh, yes!
A lot of the experiments are really simple stuff you'd have lying around in your kitchen or in a craft room.
And it's using those materials to teach these different concepts.
Oh, that was good! Ultimately, we want the kids to work through science and engineering practices, what scientists actually do to be able to understand the concepts that we're exploring.
You do a science experiment to see what happens, meaning a quote-unquote failure is also a result too.
Whenever we have a project like this and things don't go well, what would we do? Redesign it, absolutely right.
Being on Curious here made me realize that science is all around us.
Science isn't boring, it's fun.
We get some fizzy action! Rob's passion for science is contagious.
Dr. Rob has a lot of energy on set.
Energy in motion!
That energy, it transfers to the cast members.
Curious Crew has a roadshow element as well, and we'll go to schools, we'll go to fairs, we'll go to different events.
I didn't want it to just be 10 shows and we're done. I wanted the children that were involved with it to feel inspired and empowered to go out and talk about their love of science. And we've created curiosity guides, the lesson plan behind each of the investigations in the show. Parents and teachers can download them from the website and use them on their own.
This show really makes science and engineering accessible, and it helps children realize that if this is something they're passionate about, they could do this for a lifetime.
We can have a lot of fun with pulleys, don't you guys think?
Yeah! At the end of every show, we point at the camera and say,
Stay curious!
And keep experimenting.
There's so many ways that science touches our lives, and if you don't stay curious, you could totally miss out on those.
Remember, my friends,
stay curious.
Stay curious.
Stay curious.
Stay curious.
And keep experimenting.
And keep experimenting.
That's gonna go at the end.